All right, this is the next keynote speaker. I haven't seen him, so I hope he's with us today. He's here. Super. I was a bit nervous. I'm very pleased to welcome on stage at CYSAT 2025 for the first time Mr. Laurent Jaffart. He's the Director of Secure Connectivity at ESA. Welcome, Laurent, on stage.
Thank you very much. Can you put the slides? Yeah. So it's a great pleasure and honor to be with you today. I've been working at ESA now for 1 year. In fact, I'm celebrating today my first year at the agency as a director for communication and secure connectivity. And when looking at satellite connectivity, we're looking nowadays at connectivity which is no longer just a backup or a solution of last recourse. What we see is that satellite connectivity is an integral part of the communication infrastructure. It plays a critical role across many sectors, the satellite connectivity for transportation, emergency services, law enforcement, military users, finance sectors, but also for customers like you and me who are able finally to connect homes or vehicles that were off the grid. It complements the terrestrial networks in several ways by expanding the coverage. And we are looking at a terrestrial and non-terrestrial network integration to further boost this role towards ubiquitous, permanent coverage, seamless mobility, and continuous services. But within the current geopolitical context and landscape, the need for foreign and resilient solutions has never been more pressing. We need to address those challenges by looking at two priorities. First, it's a question of ownership. It's a question of control of operations. It's about sovereign critical technologies and products. It's about a strong industrial supply chain. The second element is around the development of dual use. We need to serve both civilian and defense needs. We need robust systems. We need to enhance the resiliency and the security of global communications more effectively. The geopolitical shift have placed satellite telecommunication in a new threat landscape as well. We have seen 300 types of cyber attacks against space systems in the last 5 years, with a significant increase in the last years. We see experts in geopolitics starting to worry about cyber attacks to space systems. We see that the technological developments are not longer good enough for just off-the-shelf solution, yet we need to look at standardization. We have reconfigurable satellites. Software has made its way to the space assets. On one side, this is great news, offers more flexibility, different business cases, but on the other side, new threats. So we need to look at how to cover the different networks. We are talking at ESA about 3D networks, terrestrial and multi-orbit networks. And we need to look at security and resiliency of the satellite connectivity now more than ever. We are supporting different missions. We are working in my directorate both for commercial purpose, but also for this dual-use purpose. We are supporting the European Commission on the IRIS² program. We are working on what we call 4S. I'll come back to it afterwards. We are looking at collaboration between industry, institutions. We are looking at how to innovate and create sovereign solutions. We are also looking at optical communication. Quantum key distributions, we have a program called SAGA that will prepare for Euro QCI, and optical networks that we are demonstrating with Hydron that will fly late 27. When looking at space system for safety and security for us, we are bringing support to the development of in-orbit validation. We are looking at demonstration of potential operational services. We are looking at the development of security technologies and solutions to answer the ever-changing cyber threat landscape. We need to address the needs of our customers, and we need to detect the vulnerabilities. We need to test permanently our assets. We are working with industry in partnership on more than 20 different activities, and we are looking at topics such as post-quantum algorithm, scalable management systems, optimized VPN, quantum key generation, and quantum key exchanges. The second objective we have is to assist European space companies in building knowledge, expertise, practices, and cybersecurity expertise. We are looking at how to develop practical tools, how to facilitate knowledge exchange, and the development of a supportive ecosystem. We signed in Estonia earlier this year a cyber range. You know, Estonia, small country, but also the host of the NATO Cyber Command. We are very proud of this contract because we are not just working with the large companies, we are working with the entire ecosystem. And here, in particular, potential promising SMEs and startups. So we'll be looking to test the security of space solutions and technologies. We'll be looking at conducting cybersecurity exercises to simulate real-world threats and to improve our response strategies with our space assets. We are also looking at how to develop expertise through specialized training, and this cyber range will be open to the other member states. When looking at cybersecurity, we need to also be able to test in orbit. And soon, we're going to launch an invitation to tender to work on an advanced and flexible in-orbit laboratory. What we want to do is to move from an offline, on-the-ground testing to testing real threats in orbit and to see how the hardware and the software respond to these evolving threats. So we call it Stelios. Stelios is aimed at enabling industry to test and assess in real space conditions a variety of innovative technology test cases, such as new, novel crypto mechanisms, secure network protocols, but also routing techniques. We have a key role on IRIS². You know that we signed this contract, this concession agreement with the European Commission and a consortium called SpaceRise at the end of last year. In fact, these are 3 different contracts. We have a first contract, which we call the ESA Partnership Project, that is aimed at maturing low-level technology, that securing the critical path on developments of critical items of the system. We have a contract from the Commission with SpaceRise to operate the service, and it's a 12-year concession agreement. And we have a third contract between the Commission and ESA to support the Commission in the monitoring and the advancement of the program. We have a holistic security approach with different layers in orbit. We have the support of the ArtGov system, something that we call the LightGov system. LightGov is defined as a service operated commercially, but for governmental benefits. And there are two great examples for this LightGov services: maritime surveillance, the management of the territorial waters, extraterritorial waters, illegal activities. On the telecom side, the development of the VDES, the ability to monitor where the ships are, and in particular when they switch off their AIS or VDES systems. But also for air traffic management. Today, we see congestion around airports. We see the number of hours you are maybe all losing waiting either at the airport or in the air. And we see that the problem comes from the over-interrogation of aircraft, the inability to predict the traffic incoming because the traffic over the ocean is not monitored. But we're also looking at the connectivity to the cockpit, the safety of life link. And here, satellites are an evident solution. So we'll look at traffic segregation, densification of routes, flexibility of services, but also the question of sovereignty. Today, we are not independent in Europe to provide those services. The IT security management will be key. We're looking at cybersecurity for these ArtGov, LightGov missions. It will be embedded into the system. We are looking at security by design. We are looking at the question of interoperability as today we have proprietary systems. In Europe, we are pushing the standardization route. But standards are known, open, and potentially open for additional vulnerabilities. And then we're going to look at security monitoring with the question of detection, investigation. So we are looking within this IRIS² program not only at offering secured connectivity, but potentially some additional missions that will be disclosed a little bit later in the life of the contract. When it comes to quantum, for some of you, maybe black magic. For me, it is at least. What we see is we have the ability to protect ourselves with quantum key distributions from the post-quantum threats. In fact, we have seen a debate. Should we invest in quantum key distribution? Should we invest in post-quantum? The reality is you need to invest in both. You don't have a choice if your adversaries are developing the technology faster than you than to have the ability to exchange keys on a regular basis. And what we see today is the development of technology, sometimes still very immature, sometimes still in the labs, but we see the need to help this maturation, get these technologies out of the lab into real-life experiments, and potentially later on accreditation of systems that would be used for governmental users. So we are preparing a ministerial conference. I don't know if you're familiar with the ESA processes. Every 3 years, we have a council at ministerial level, 23 member states coming together and voting on the budgets for the next 3 years. Those topics are priority topics for us, and we expect that with the budgets we would get from each of the member states, we would be able to feed the industry and the maturation of this technology. It is important to see that when we talk about accreditation of systems, very quickly we have the national authorities looking at the standards, looking at the accreditation, and we need to work together with the national QCIs. When it comes to Euro QCI, this will be inserted into IRIS², into the second generation of IRIS², and this will be a dedicated layer that will fly within this constellation. And in fact, IRIS² will be a communication backbone with different missions around this. My colleagues have mentioned in the last days that we're doing on this constellation called ERS, European Resilience for Space. IRIS² will provide a backbone of connectivity, but not only to quantum, but also to the ability to task and retrieve images from space. When it comes to optical links, in fact, Europe is world leader in optical communication. The United States is relying on European providers for the inter-satellite crosslinks. We should not be shy of what we have done. It started a long time ago. It started with programs like EDRS. Those technologies at the time were very immature. The size of the terminal were very large and very heavy. We are seeing the process of miniaturization. With Hydron, we are developing a system that will be composed of multiple elements. An element 1, a LEO ring. An element 2, a LEO collector capable of connecting optically to the ground, capable of connecting in GEO or potentially in MEO. We are developing an optical network. And we are proposing at the next ministerial to go and develop element 3, which will be customer satellites connecting into the Hydron network with additional optical links. Technology is developing. The prices are falling, but we have a real market ahead of us, real quantities, and these quantities are opening new business cases. The ability to prepare for the future is also a call for action. We are looking at new threats. We are looking at a change of mindset. We need to think that not only military operations are going to be targeted, it's a dual-use system. We need to look at innovation, but we need also to look at cost-efficient solutions. We need to enhance our awareness. We need to design telecommunication assets and systems with security at the center and with security by design. The resilience by design is the ability to withstand and dynamically recover from major disruptions. It is mandatory that we look at redundant, fault-tolerant, adaptive, self-healing networks, that we look at system flexibility, adaptability, and reliability. We need to prevent and minimize system downtimes. We need to look at our system no longer in isolation, but we are interconnected. We need to think in a system-of-system approach. And this means we need to provide flexible, but also dynamic backup solutions. A multi-orbit system is an element of the answer. We are able, through a multi-orbit system, to dynamically reroute from one orbit to another. One of the previous panel was talking about AI. AI in networks. This is a brand new field where there's a lot of work to be done. It's no longer the machine learning. It's very difficult to predict the bottlenecks in the network. And AI for telecommunication is an area where we see potential for Europe to regain leadership. Considering the geopolitical context, my directorate, the agency, is committed to support the national, the European institution, but also industry to strengthen our capabilities in the SATCOM sector. We think that this high resilience by design is an area in which Europe has all the strengths possible to rival on the global scale. And we look forward to further collaboration, investment, and engagement with you. Thank you.
Thank you, Laurent. Please have a seat. We have some time for questions and answers. Don't hesitate to use the app to ask any questions to Laurent today. Thank you so much for the presentation. While we wait for the questions from the audience, I have a few. Maybe starting with a very basic questions. You presented a number of initiatives here, 4 or 5 initiatives. How would you describe the level of importance of each of these? I believe, like for example, Stelios is a much smaller project than Iris Square for the secure connectivity department at ESA. What would you say would be priority number 1, 2, 3, 4 in terms of volume of work, in terms of involvement of your staff?
Is it working? Yeah. I don't think that the question of competition between projects is necessarily the right one. What we see is we are in a tough time on the satellite telecom market. The disruption that the constellations have brought, and in particular vertically integrated players like Starlink has brought, is calling for a multifaceted response. What we see is we've divided our work around 6 pillars. And the 6 pillars are all important. The 6 pillars are in fact the 6 priorities. So priority number 1, we see a huge opportunity for direct-to-device. Direct-to-device is not only direct to your cell phone, direct-to-device is any devices, cars, potential objects, and we're talking about narrowband. The time to market is going to close by 2028, therefore now is the time to act. And unfortunately, all of this is based on frequency rights, and the frequency rights are in the hands of few actors. So we are proposing an initiative on direct-to-device, and we're proposing a brother on direct-to-device gov to look at a security layer and to provide governmental direct-to-device capabilities. The second pillar is your competitiveness. And you should see ESA as a multiplier. When you're looking at developments, we can amplify. We can bring together several companies into a consortium. We can pool funding from different member states and multiply what a company was trying to do on its own at a much greater scale. We need to look at maturation of technology, but we also need to look at the constellations. And the constellations mean we need to enter into an industrial scale in space. We've seen that Europe was at the forefront of the constellations with TAS on Iridium, Globostar, with Airbus on OneWeb. But now that we are getting into the second generations, we have seen Starlink coming in, Kuiper, Chinese players. So we need to catch up. And to think about production at scale is key. I had a discussion, I will not name the product or the people. For one equipment, I asked, how long does it take? The answer is 6 months. I'm like, good. For 2 equipment, well, 1 year. Okay, for 60, well, 30 years. We need to think and design our products to manufacture at scale. That's the second pillar. And that ranges with a lot of technologies throughout the complete ecosystem. The third pillar is very, very key. It's all about spectrum sustainability. Today, we see an explosion, an exponential growth of assets in space, all using spectrum. Spectrum is a finite resource. And we are starting to see more and more interferences between operators, which are sometimes doing it unwillingly. And the problem we have is that operators are only able to monetize their frequencies if they're able to provide a service of quality. If the service is no longer of quality, customers will switch, they will no longer stay. And that means those operators will no longer be able to invest in the future, and the entire chain will suffer. So here we are looking at how to preserve the spectrum, and in fact, this is also a preparation for the 27 WRC, World Radio Conference, where there will be a lot of debates on can we use terrestrial spectrum in space, or should we use space spectrum or satellite spectrum? And in large countries like the US or Brazil, you don't cross the border very quickly. In Europe, it's no longer the case. And given the fragmentation of the MNOs, we see a lot of potential interferences. The next pillar is going to be around governmental connectivity. You'll find IRIS², you'll find the LightGov mission I talked about, maritime and aviation. But in fact, cyber, we put it under this. And the ability to go and test in orbit is going to be key to prepare for the future. We are not operating satellites. We are helping member states and industry to demonstrate, to mature technologies, and to go up to pre-operational services. What we want is to generate a very fertile ecosystem and ground where you can develop businesses. The next pillar is around optical technologies. And we have talked about Hydron, very key, QKD, several projects running in competition in Europe. We need to keep the leadership we have on optical communication. This is really important. But to do that, we need to work on standards. We need to work on interoperability. We should not repeat what we've seen in the past at the time of EDRS, where we were battling with the US on the standards for the wavelengths. And in fact, if some of you went to business schools, it reminds you of the VHS Betamax debate. We should look at interoperability, and the volumes are usually dictating which standard is winning. So here we have a lot of activities with the US and potentially with NATO to come to standards and adoption of global standards. And then the last topic is more of an agency topic, which is very important, but maybe a bit more futuristic, where we are looking at interplanetary communication, so lunar communication, Mars communication, and beyond. In fact, the lunar economy could boom, but we first need to provide the infrastructure. For us to provide data relay to the moon is basically to allow much smaller missions to just communicate to a relay and not trying to communicate back to Earth. So basically focusing the payload on the exploration part and not on the telecom part. I forgot to mention one point on optical. We will start to seed what we call quantum information networks. And as some of you know, photons do not travel very well on the ground. And the quantum principle is an exchange of photons. And today, black fiber will allow you to reach between 75 and 100 kilometers. Whereas in space, because of the vacuum, you're able to get those photons across much, much longer distances. And in fact, we could reinvent the internet of quantum computers. But here, we are still very, very much at laboratory level.
Thank you. Very last question. We're almost done with the time. As I said, like we're trying to bring all the community together at CYSAT. We have startups, industries, academia, researchers, agencies. How can we work with communications and secure connectivity? What ITTs, what is your recommendation to get in touch with you, with your team, the opportunities that for Stelios, for maybe participate in cyber range exercises, and so on? How do we engage?
So my contact details are on the ESA website. The team is also there. We have a portal for ITTs, which is called ESA Star, where all ITTs at ESA are public, so you can see. If you want to propose a project, we have call for ideas. Some of them are permanently open call for ideas. Others are more thematics and also published on ESA Star. And what you need is the support of your member state. So if you're in France, you need the support of CNES. If you're in Germany, DLR, and so on. And the national agencies are looking at ESA as a multiplier for European projects. If your project is national, very likely your national agency will support you nationally, and there is not necessarily a need to bring it at ESA. If the projects are cross-border, we are there to facilitate these cross-border activities. We are there to pool budgets together. And depending on the size of your company, depending on the activity, there are different levels of co-funding that apply. We're trying to simplify all of these rules, but again, we have a lot of information on the website. There is a dedicated CSC website, which I encourage you to visit.
Super. Thank you so much, Laurent. Thank you so much, Big and Pablo. Thank you for being with us today. And before we wrap up this morning session, I would like to invite Claudia Fiorentino to join me on stage to promote actually a space cybersecurity course organized by ESA very soon. Thank you, Laurent.
Thank you.
Grab a mic, Claudia, and please explain us what is this for.
Yeah, okay, so thank you everybody, and thank you to CYSAT for supporting us in this initiative. The European Space Agency, especially our Connectivity and Secure Communication Directorate, believes a lot the importance of boosting the awareness of our stakeholders, and so we organize training. And this summer we are launching, in cooperation with the Oxford University, a new training on secure space communication system. And today and in these days we have been announcing this training, and we are at the stand, ESA stand above, so if you want more information, please join us. But we also proposed CYSAT to organize a lottery. We think that young talent needs to be boosted and supported, so we are offered the sponsorship of one student that is registered to CYSAT. And today Laurent is going to extract one name of the student that will be with us this summer from the 8th to the 11th of July during this training. And then we will extract one people that put kindly their business card in the basket. So people that is interested in joining, and they can be able to join the training with a discount of 20% to the registration fee. So, Laurent, please, let's start with the students.
Okay.
No pressure, Laurent.
Innocent end.
Let's see if the students are here. I don't know. Are there any students that have been okay?
Yeah, there. Yeah.
So, Mrs. Anna Bleshova. I'm sorry if I did not.
Whoa, good.
Yeah. There you go, Anna. Please join us on stage. Congratulations to the winner. And this is a week-long course with cybersecurity experts in the UK.
Secure space communication system. So it will be an intense week with us. Very happy to have you on board. And there will be 4 days. The first day, Laurent will be with us. We have a geopolitical introduction to explain why secure space systems are so important now in this situation. And then we will have more technical speech, and people coming from academia, from industry, from ESA will be the lecturers, and they will explain how a system for SATCOM in space is designed, and what are the techniques for ComSec, and what are the new threats that we are facing. We have Clémence Poirier that is also joining stage later, that will be there with us. Professor Barb Prenell from Kew Leuven University, a very big expert on cybersecurity. So let's see who else from industry will be with us.
Second chance.
And we have César Carmona.
César, here you go. Bravo to you. Super.
Thank you to CYSAT.
Thank you so much, Claudia. Yeah,
thank you.
We'll see you for this cybersecurity. All the infos, I believe, are online if people want to sign up and register.
On the webpage of Oxford, and again, we are up there in the ESA stand with all the information. Thank you
for
your
attention. Thank you so much, and see you in an hour after lunch. Thank you.
Congratulations, Anna.